for medical image processing, for converting your 2D image stacks, 2D DICOM data to be specific from maybe from MRI, CT, or all modalities of CT, MRI, to 3D models for various applications. There can be applications for simulation, 3D printing, and implants design, surgical planning. Vast amount of number of applications there can be for 3D models after you have converted them from MRI or CT images. So as for my profile, I'm working here as an application engineer from past 2 years, and before that I was working with various kinds of CAD softwares, CAD packages, and next I would like to introduce you Dr. Karim Gain. So he's a business development manager at Synopsys Simpleware Group. He manages the global sales team, partnerships, and is involved in technical marketing, content development. And I will just move my screen.
Hello, my name is Karim Gench, and I'm the Business Development Manager for Simpleware Software at Synopsys. And I will be giving a brief presentation on the Simpleware software solutions going from 3D images to models for things like 3D printing, surgical planning, and patient-specific workflows. Thank you for having me for this presentation. Now, to start off, I'd like to give an overview of the Simpleware product group within Synopsys. So we are developers of high-end 3D image processing software, and we have dedicated sales, support, and services teams internationally with a global presence, and we work with customers in clinical, life sciences primarily, and then in areas such as materials and manufacturing. And we have a global presence with our main center of gravity within the UK, with folks in Germany, Southeast Asia, in India, the US, and South America. So what does the Simpleware product group offer me? I'd like to start off with looking at patient-specific surgical planning, and an example on that is where it's based off of preoperative CT or MRI scans. So this is where you can do things like take preoperative virtual measurements, carry out virtual planning, example of resecting bones virtually, checking the fit of implants and things like that, and also 3D printing, where you can obtain a physical model of a patient's anatomy for pre-surgical planning or training. So the idea here is to cut down on intraoperative time and improve clinical outcomes. Looking at patient-specific device or guide as an example, this is also a similar workflow going from a patient scan of a CT or MRI. It's also you can generate patient anatomies, checking fit and form of devices, where you can also tailor the device guides to the patient requirements. So for example, incorporating patient-specific design into your workflow, connecting with CAD tools such as SolidWorks and fitting that into your workflow. And then also you can do things like exporting volume meshes for simulations for in silico performance or in silico clinical trials. So the idea here is to find the perfect fit for your patient. So we have a lot of different applications. On the left, you can see more of the consumer products, consumer electronics areas, protective gear, wearable electronics, shoes, clothing. So a lot of these types of companies who do simulation or design based around human anatomy use Simpleware to gain access to realistic patient-specific geometries. And on the right side here, you can see things such as implants or guides for and for pre-surgical planning. Anything with a patient-specific workflow where you need to go from that image to a model and feed that into your workflow, whether for 3D printing or design or simulation. You can do physiological simulations, and on the bottom showing some 3D printing. So looking at our software, so what we do is we offer a software solution that goes from images to models. And it's a GUI-based high-end 3D image processing platform, and it provides a comprehensive range of tools for things like visualization, filtering, segmenting your image data. You can see the GUI interface on the right. You have the 3 orthogonal views of the image data and the 3D reconstruction on the bottom right. You can bring in the CAD geometry, position it, label different parts, different landmarks, things of that nature, and export models from there for CAD, 3D printing, or even finite element or computational fluid dynamics modeling. So really going from the image again to the model and bridging that gap. And then anything you can click within the script, the software you can script within Python, C#, Visual Basic, and you can automate quite a bit of the workflow through macros and things of that nature. So what does the software do? Going from left to right here, does measurement and analysis, segmentation, processing of your image data, generating models, 3D image import and visualization, CAD and image integration, and then again, scripting and automation of your workflow. So these are all the different areas where the software can help you going from the image to the model. So getting a little deeper, looking at 3D image import and visualization, this is where you can import the stack of DICOM data, which is typically the type of clinical data used, where you can visualize your model, do things like volume rendering and things of that nature, and do basic image processing. Segmentation is a big area of concern in this area where it can be a bottleneck, but we have a lot of tools from completely manual to fully automatic tools. For example, here this shows the 3D editing tool that you can use for the segmentation process to, for example, split out the femurs and the pelvis from each other from the segmentation with a few simple clicks. We also have automatic segmentation tools, so AS Ortho, AS Cardio are tools we have where we can use machine learning based AI to fully automate the process of segmenting the hip from CT, the knee from MRI, or the heart from CT as well. So this is segmentation and landmarking. And so this is just a closer look of the knee MRI results and the hip CT results. And then this is an example of when we applied the automated tool to 4D cardiac data. So we were able to segment each time point automatically in just a matter of minutes. And then this was an example of a little animation we put together. So this is unprocessed, not touched by a human, just simply imported and segmented. And these were the results automatically. So for example, here, this is that 3D image painting, the split merge tool. So you can automatically paint and split these tools, split these sections from each other. So there's a whole host of segmentation tools that are available, different types of measurement and analysis. For example, here showing the bone mineral density or fitting a sphere, measuring these distances between them. Then there's the CAD and image integration. So you can import a CAD geometry into the image space, position it, and do your design, looking how your device fits, doing measurements, angles, things of that nature. For example, here we have a group that did modeling of the foot with the shoe. So they imported the CAD geometry of the shoe and fit that over the foot. Then also we have a new tool called Design Link. So we have direct linkage to SolidWorks. So you can push and pull information directly between the two tools. If, for example, if you have the two windows open, you do an edit in one, push, pull, it'll bring it back into Simpleware and vice versa. Then the most important part for most people is the model generation. So this is the model that you export either in STL, 3MF, CAD in a NURBS step or IGES file, or a volumetric finite element mesh for tools like Abacus, ANSYS Console if you want to do multi-physics simulation. And for example, here is the bone mineral density mapped to the model based off of grayscale and showing it in the color scale. And on the right here is a multi-domain model of the human thorax. And again, as I mentioned, everything that can be clicked can be scripted. So you have full access to the API. You can go do a macro recording showing here. You can convert the log of each step that you've completed, convert that into scripting. So those are the ways you can build the scripts. You can also build plugins, so actually your own buttons within Simpleware, really make the software your own based off of your workflow, or a fully customized solution where we can pull in our R&D team and help you generate some fully customized solutions. So The advantage of Simpleware is that it is state-of-the-art technology, has robust and proprietary algorithms with very good segmentation tools. It's very easy to use. Excuse me. With a user-friendly interface, and it can be customized through scripting. And then our support is top-notch, where we have our application engineers ready to help you and provide support to you and your engineers as you bring the software in and start to deploy it. And we do have some regulatory certifications. So for example, we have ScanIP Medical, which is FDA 510K cleared, and the CE marking as well of the tool. So if you want to try Simpleware for yourself, you can go to our website and get a free 30-day trial. You can receive a fully functional version of the software product. You can contact our support team for any advice or help to set up your workflow. You can also arrange a personal demonstration of the software via WebEx. You can send us your image data. We can show you how to go through the workflow and produce the models that you need. We have a whole library of videos on our website, where you can download the data sheets as well to get information there. Or you can contact us directly, simpleware@synopsys.com, and we'd be happy to route you to the appropriate person or account manager to help you with this tool. So really, I'd like to end it there and just end with a summary as a take-home message that Simpleware software provides a solution to convert 3D images into models. The type of 3D image could be MRI, CT, or magnetic resonance imaging, or computed tomography, or even different modalities from that. Any sliced image data over a 3D space is the type of imaging. And then when I say models, it can be STL or 3MF for things like 3D printing. It can be CAD geometries in the STEP or IGES format, or it can be fully volumetric finite element meshes. And so these workflows are used for any kind of patient-specific workflow that can be used. And then if you want to scale it up, we have, as I mentioned, our automated machine learning-based artificial intelligence tools, where we can apply it to the hip CT, knee MRI, or heart CT. But in addition to that, we can also do a fully customized solution for any anatomy. So if you have a large scale of image data that needs to be processed, we can provide solutions for that to fully automate that process. So with that, I'll leave it there, and thank you for allowing me the chance to present at this conference.
So, that was Dr. Karim from Synopsys. So that must have given you a better idea about what the software does and what are its capabilities. So to quickly show you how this processing is done, I would like to show you a small video which will show the demonstration of the software. So let me just switch again to the. So now I will show you a demonstration video of the software, and although this application may not be relevant to everyone, but I assure you that all similar applications have the same kind of workflow throughout the image processing part. So this is a very common workflow. So now we started by importing our DICOM data. We can have a look in the DICOM preview. Now we are just doing some background volume rendering to see what data we have imported. Applying some crop function to it to select our region of interest. Then some basic image segmentation. So now we have segmented the bone region. We are using a very easy to use split regions tool to split our regions into separate masks, separate parts, and applying some filters to it to smoothen the surface. Now these are some of the basic 3D editing tools for working around with our geometry. And this is an example of how we can import and place an implant into the model for checking its fit and positioning it, which can be later used for doing simulation for load bear analysis or finite element analysis for load strength. So this is the finite element mesh, volume mesh, which can be later exported for simulation purposes to check the, you can say, efficiency or bearability of the implant. Apart from this, the software can also import models for 3D printing purposes. You can add your own internal lattices into the models, which would provide support as well as reduce the raw material requirement while 3D printing. And later on, you can export that model as a STL file for the 3D printer softwares. Now, if there are any questions at this point, I'd like to. Okay, so our software has various modules in it, which enables you to select or customize your package based on your requirement. So the modules start from Scan IP, CAD, NURBS, so various other modules ranging to simulation modules as well. So the Scan IP is our base module, which allows you to do segmentation with lots of available tools for that. And obviously that is not possible to show you in this demonstration period because it would take it can be a more dedicated session for that purpose, for showing you how the software GUI looks exactly. And the latest addition to our software is the design link module, which can be very helpful to lots of the presenters who are present here. And what it does is that it links Scan IP with SolidWorks CAD package, and that allows you to synchronize your models from SolidWorks. So let's say you are designing an implant in SolidWorks, and then you want to check the compatibility with the 3D model. So you can import your CAD model into the software and make some changes in SolidWorks, and those changes will be reflected directly in the software. So that is a kind of link that is being provided between this Synopsys Simpleware software and SolidWorks CAD package. And another additions, very important additions to our software are the automated solutions. So what those modules are is that they are machine learning algorithm. They are machine learning modules which do the complete segmentation automatically. Right now, the available packages are for knee segmentation from PD-weighted MRI scans, cardiovascular segmentation. So as we know, the segmentation of the cardiovascular system can be a very complex process and very time-consuming process. So just to give you an example, expert user could take around 3 to 4 to 5 hours for doing the segmentation of the cardiovascular system. And the automated system does it well under 2 minutes, and that is a significant amount of high value engineering time that has been saved at that point by using these automated solutions. And similarly, the same process is for the knee segmentation. So if you are working in batches of knee images, so you can utilize those modules for doing automated segmentations by just importing the data and doing the segmentation completely automatically, and later on exporting it for 3D printing purposes or simulation purposes or surgical planning purposes. After that, we have AS Ortho, which also includes Also includes your pelvic region segmentation. So pelvic region segmentation can also be done completely automatically. So sometimes that can also prove a very tough task to do in a short amount of time. So just to give you a benchmark idea, so an expert user takes around 30 to 40 minutes for doing the segmentation of the pelvic region accurately with the smoothings and applying all the filters. The automated solution takes around 2 to 3 minutes for doing this automated solution based on machine learning and deep learning algorithms. Similarly, the knee segmentation takes around 2 minutes for the segmentation from the PD-weighted MRI scans. So right now there are these three sections for which machine learning algorithms are available. So apart from this, Simpleware also provides you services for generating your own machine learning algorithms. So let's say you are not working with cardiovascular systems or hip or pelvis region, and you are working with some separate anatomy part. So in that case, you can work with the Simpleware team to generate your own machine learning algorithm for automating your tasks which require a lot of time. So you can automate your segmentation part as well as export part also. And as Dr. Karim informed in his presentation, whatever you do with the mouse can be automated using the scriptings. So you can just just drag and drop, and your the operations that you have done, the processing that you have done, will be converted into a Python script, which can be later imported into a software, and just you can run it in batches to work through various data sets. So as most of the participants here are mostly related to 3D printing and orthopedic application area. So I would suggest that this you have a look at the software. We are also presenting the software in our booth. We also have a booth in this presentation, so you can come over to our booth to have a look at the software. And if you provide us some time, we can later on also schedule an online demonstration with you to showcase our software and capabilities, whatever capabilities are available, and how this software can be beneficial over other softwares that are currently available in the market. So as I informed, you can visit us at the booth of our integrated microsystem. So to summarize, we are the authorized distributor. We are the representatives for this software, Synopsys Simpleware, in India, and we look over the sales and support of this software in our country. So other than that, these are some of the ways to contact me, and I'm available at these methods. So you can have a look at it, and if you require any kind of assistance in similar area, if you are looking for some medical image processing solutions, so you can contact us, and we will be happy to provide you your answers. So thank you everyone for joining today, and I hope to see you in our booth as well to discuss further of your requirements. So thank you very much.